In this lesson, we'll go through each attribute in detail and explain how to use them. First, in the previous module, the palm color and the downward-facing color have both been adjusted to purple. By default, the upward direction is the y-axis. This is defined in local space. This makes it easier to distinguish each module and its up-down orientation. New features include the ability to control the scale of controllers. For example, if you feel the controller is too large, you can adjust the scale multiplier 0.8 will scale it down. You can set this based on personal preference. Next, let's look at the controller attributes. Each controller has a transform to 0 attribute by default. This is the adjustable attribute panel for the controller. Normally, every controller contains an Enumcraft hierarchy. When you click here, the control panel below will be hidden. You need to select Enumcraft for the control panel to appear. Let's start with the chest controller. The first attribute is Follow p-rot, which means following the rotation of the abdomen. This option is enabled by default. If you turn it off, when you rotate the abdomen, the child hierarchy will not follow. When enabled, the child hierarchy will follow the rotation. After disabling this option, the second attribute is Position locking. By default, free rotation is allowed. When turned off, rotation is limited to a fixed position. When turned on, free rotation is restored. Next is the Squash feature. When disabled by default, stretching operations will not produce a squash effect. Once enabled, squash effects are applied. This feature is a combination of the previous two. When enabled, the first two options become unavailable. For example, when you move the lower body, the upper body will remain completely still. This is useful for creating specific effects. The Keep Length option is used to maintain bone length. When scaling is enabled and Keep Length is also enabled, all three bones will scale uniformly. If it's disabled, each bone will scale differently. The actual result depends on the specific situation. The Joint Space Control attribute allows you to slide the controller. When the controller slides, the bones will deform based on the controller's position. When you need to adjust the exact shape of the bones, you can enable the Interjoint controller of Joint Space Control. This allows you to fine-tune the bone positions. Of course, the final result depends on the quality of the skin weight painting. Automatic skinning is fast, but it only provides basic weights. For higher quality results, manual weight painting is required. This space value can be reset to 0. If you feel the controller is too large, you can use this attribute to scale it down. This allows for quick adjustments. The head has similar controllers as well, because they share the same module, only with different shapes. Each arm and leg has a controller labeled with AC, which is used to adjust various arm attributes. It's recommended to avoid using this method whenever possible. If certain attributes are adjusted, it may cause some functions to break, because its position usually has minimal impact. The ICFK attribute is used to switch between IC and FK. This is an IC or FK toggle switch. 0 represents IC and 1 represents FK. When switching, the FK stays where it is. And the same applies to IC. First, reset it to 0. Now let's demonstrate the ICFK blend function above, which enables seamless IC or FK switching. For example, at this point, I move and adjust the IC position, setting keyframes for the arm. For instance, set it to this pose. Then click this button. The interface will briefly flash and switch to FK mode. The arm position remains unchanged. When switching again, there will be no flicker, because the system has already calculated the positions. Now move the FK controller. And it will switch back. When there is no stretching, IC and FK can be switched seamlessly. However, if the arm is overstretched like this, issues may occur during switching. The first switch may look fine, but when switching back, the joint axis may twist and change. The solver becomes unstable. Although the system will try to solve to a relatively correct position, if you notice any issues, you should first switch the related controllers back to FK mode and reset the FK controller values to 0. Then perform the seamless switch again, and everything should return to normal. This switches it back correctly. Therefore, the seamless switching feature should be used when there is no stretching. This ensures proper seamless switching. The next attribute is FK follow, which works similarly to the body controller. When enabled, in FK mode, the arm will follow the body's rotation. When disabled, the arm will no longer follow the body rotation and will only translate accordingly. This is useful for creating specific animation effects. Enable it as needed. IC stretch controls IC stretching and compression. First, switch to IC mode. When enabled by default, stretching the controller will extend the entire arm. When this option is disabled, the controller can still move, but the arm will keep its default length and cannot be stretched. This is simply a toggle. The ICSoft feature makes arm movement smoother. For example, when it is disabled, quickly straightening the arm will cause the elbow to snap abruptly. After enabling ICSoft, the motion becomes much smoother. Please observe carefully. When disabled, the arm snaps straight immediately. When enabled, the movement becomes softer. The IC Pull Lock feature locks the elbow to the pull vector target, allowing precise control of the elbow direction. Please note, try not to move. The upper level groups of the controllers. Because controller zeroing relies on the original positions of these groups. If these groups are moved, the controller positions will become incorrect. Specifically, under the Other hierarchy, the automatically created gray groups should not be moved or renamed. However, objects under the controller and bone hierarchies can be adjusted safely. The following attributes are related to squash, stretch, and curve deformation. For example, in the current state, the arm can only stretch without any squash effect. After enabling squash, the arm becomes thinner while stretching. In addition, the arm can bend. Forming a curved shape. If the curve option is disabled, the arm will remain straight. When enabled, it can form an arc. This is the combined result of squash and stretch. After resetting the controller to 0 and then moving it, the entire arm will show a squash effect. This effect can be adjusted through the related attributes. The leg controllers work on the same principle, after enabling the corresponding options. You may sometimes encounter cases where a feature stops working, for example, after using the teleport function. You can try switching modes once, and then switching back, and the function should be restored. When you find that an attribute is not working, try toggling the IC or FK switch, and the behavior will usually recover. Keep length when stretching with this option disabled. The stretch amount of each bone segment will be uneven, and the end bone will stretch more. After enabling Keep Length, the 3 bone segments' scale values will remain consistent. The next attribute is rotation, used to control the twist bones when rotating the arm. The twist bones rotate as well. This attribute controls their weight value with a default of 0.5. The range is from 0 to 1, and it adjusts the rotation influence of the upper bone. 0 means no rotational influence. 1 means full rotational influence, and 0.5 is a balance between the two. The rotation setting for the lower bone works the same way, with a default value of 0.5 as well. You can enable or disable it, depending on whether you need a twist effect. This attribute adjusts the default length of the IC bones. First, reset the IC bone rotation values to 0. For example, when adjusting this value, you can change the length of the hand. The hand will become longer accordingly, which is the purpose of adjusting the IC default length. Click Rest to restore the default values. When creating controllers, if you need to reset them, simply click Rest. The scale parameter. It controls the scale of the palm or foot. All of these are on the AC controller. This is the finger arrow controller, with segments matching the finger joints. This parameter controls the strength of the grasp. For example, the first finger segment. The default value is 2. This is the finger squash feature. When moving this controller, the fingers won't stretch. There are 2 tail systems. Spring chains and FK chains. If a controller has these attributes, it's a spring chain. This character uses an FK chain by default. It can only perform per joint FK motion. The follow feature works similarly. All chain parameters are on the front controller. For example, ears are also chains. Their parameters are on the front controller as well. When follow is on, rotation follows. When it's off, it stops following and stays independent. So how do you use a spring chain? The basic settings are the same. When squash and stretch is enabled, stretching the controller will extend the chain. When squash and stretch is disabled, stretching the controller no longer affects the length. The chain won't be pulled out. This is the squash and stretch effect. The follow feature works the same way. When rotating, it follows if enabled and stops following when disabled. Next are the spring chain specific effects. After enabling this option, let's check how it works. Here's a preset animation showing up and down motion. Once enabled, the chain starts moving. If you move the bones, you'll get soft floating motion. This lets you quickly and easily create animations, like subtle eye jitter. The first parameter controls the spring strength. For example, set to 100. The real-time jitter range is smaller than before. Set it to 200, and the motion becomes larger. The second parameter controls the jitter amplitude. Higher values make the motion more responsive. This is the damping parameter. Next is the tension parameter. Imagine holding both ends of a spring with your hands. The tighter you pull, the less soft the swing becomes. If the tension is too low and the spring isn't tightened, the motion becomes very soft. So this parameter needs fine-tuning. If set to extremely, the motion may become unstable. Below that is the start parameter, which defines the frame where spring calculation begins. By default, it starts from the first frame of the current range. This is a simple floating effect. For more complex setups, use the Dragon Breath ribbon tool. It offers more detailed controls. including softness and dynamic solving. Just map the controllers to use it. This button resets all parameters to default. For example, after creating an animation, the bake function bakes all animation data onto the tailbones. If you're not satisfied, click Unbake, which removes the baked animation. After baking, the animation is finalized, and keyframes are stored on every controller in the chain. To remove this animation, just run Unbake on the corresponding controllers. The last feature is Export. Export using the button on the master controller. Important note: this action is irreversible. To export to other software, controllers must be converted to pure bones. A confirmation dialog will pop up. This will delete all controllers, so the rig can be exported to other software. After that, the controllers are no longer usable, and the bone hierarchy will change. After clicking Yes, a second dialog appears, asking whether to bake the animation. If not needed, click No. The system shows the current frame range, for example, frames 0 to 30. If you need the animation, click Yes. You'll then be asked whether to keep the original bone hierarchy. Keeping it is recommended by default. After baking succeeds, a successful message appears. Once finished, the model and skeleton can be exported to other software. That's everything about the export feature. Thanks for watching.